Hi, welcome back. So we are in Chapter 3, Descriptive Analysis on Distribution section. That's to discuss density distribution. We have mentioned earlier having a variable x that have continuous possible outcome that will follow a kind of a density distribution. So let's go ahead and explore the possible way of actually unpack this vector into a density distribution. Now in this example, I'm going to assume that you have variable x which happen to indicate the height of a subject. The same exact procedures by getting number of subject as your sample, you are actually constructing a vector. Our aim was to construct a table, indicate the distribution of those possible values. We need to do some work on this vector to unpack this vector before we unpack it in the form of a table. First thing maybe we can do is to sort in ascending order. For example, the minimum value was like 152 and the maximum was like 179, maybe 8, something like that. Next thing you may want to do is by creating a group. In this case, maybe you decided to create like 3 different groups, 150 to 160, for example, and then from the 160 to the 170 or so, and maybe from the 170 to the 180. So here's my G1 group, and here's my G2 group, and here's my G3 group. Now things getting much more familiar to you, I think so. The total number of people fallen within group 1, it means their height was larger than or equal to 50 but less than 60. You've got a number of 3. The second group, for example, they were like 6. The last group, maybe they were 2. Get the total of all the groups, which must equal to the n number sample, which is actually just 11. Subject could maybe construct a percentage if you like. Now I'm going to show you something maybe also you want to do on the table. What is the middle point? The midpoint of here, for example, is 145. The midpoint of group 2 happened to be, for example, 165. And for the 30 group is 175. Use the bar graph as I did before. And I think the idea is quite clear to you. You might create something called a histogram. On the x-axis, you construct the possible values from the 150 to the 160. You have another interval here from the 60 to the 70. You have the third interval from the 70 to the 80. The y's indicating unit of 1, 2, 3 if you like. You can just go ahead and a graph looks like this at the end. Something similar to that. Alternative, I'm going to show you something else. I'm going to use this middle point. Now, what in the middle point is telling me, in the first group, I got like the 145, which is somewhere here. And the second one is 165, which happens to be here. And the 175, which happens to be here. Y-axis here. Again, 1, 2, you got the 3 here, and then you got the 6, and then you got the 2. Now, if you connect this, it will look like this. This kind of a graph is called a polygon. So you have options here, but the most important things is actually the step of unpacking the vector when it's continuous into ascending order, creating a group out of it, and then you start the normal procedure by creating your table. Later on, you can choose any of these graph presentation for your continuous value. Doing so, it helps you to visualize the distribution of variable x when it has a continuous value as the height, for example. Now we have come to the end of learning about distribution. Either the values or the scalar happens to be discrete or happens to be continuous. Next, we need to look at how can we capture this central tendency. That's exactly what we'll do next. I will see you then.